So this video will be about the things that affect the regression to the mean, things that affect the regression to the mean. And the big question is, how much do you regress? If you've got a certain sample measuring a certain something, how much do you regress if you're going to measure things serially again and again? The example we used was OPS year to year, and hopefully you understand that we have to regress to a certain level given the sample. Two things impact how we go about regressing to the mean. One is the spread of the talent versus random variation, and the second is sample size. I will describe these in this video. What is spread of talent versus random variation? Different metrics, different statistics have different spreads in talent. And we talked about regressing to the mean on the extremes. If it's all luck and no talent, say in a coin flip, all luck, if it's all luck, the distribution of measuring that is going to be extremely small. If it's going to be a straight line. If this is the population, all people fit on the same population. There's no variability in the population. As opposed to another measurement of something, say in the population, you would have a normal distribution of the measurement with mean, median, mode, descriptions of spread. So this is what we're talking about when we're talking about the spread of the talent. If you have a smaller spread in talent, your distribution is going to be a little closer. And you can see these ranges of distributions I'm drawing here, from no range in distribution where it's all luck versus the spread of talent moving as we go further and further out. Now, if it's no luck and it's all skill, it's going to be a huge spread of talent. So this is the case of all skill. And this is rare, but we gave the example of Aroldis Chapman and his over 100-mile-an-hour fastball. So fastballs are similar to all skill, and coin flips are similar to all luck. And this is the spectrum, the range of ideas from really luck-oriented towards really skill and talent-oriented on this side. So the spread of the population, the spread of the sample that you get in the population is here, and that's what we're talking about. So think about these spreads as we talk about this. A larger spread means a smaller regression amount. So if I'm on this end of the spectrum, and the population is very spread in whatever I'm measuring, if it's more like this than this, okay, that means a lower regression. So out here, it's lower regression. Now, regression meaning how we move back to whatever the mean in the population is. So if I'm over here in my sample of things, I'm not going to regress as much as if I'm over here. If I'm over here in this sample, I'm going to regress tremendously to get back to this kind of distribution, this kind of sample, okay? Where there's a lot of luck and randomness involved, I have to do a large regression. So on this end of the spectrum, I have to do large regression if I'm living away from the mean. I really have to regress back to understand my next sample, I've got to think about getting much closer to this. If it's a larger spread and I'm sampling out here, I'm not going to regress as much. I'm going to regress some, because you always do some regression because there's always some noise. But this is the basic idea. A larger spread means a smaller regression. The regression being this idea of the second sample, the second time you're measuring something in the metric, you're going to regress more towards the mean. Okay? So keep this in mind. And in baseball terms, if you're interested in baseball, understand that BABIP is ranging from 320 to 280. OPS has a much larger range. The spread is much different in both of these metrics. BABIP is more like this. OPS is more like this. So OPS actually doesn't regress as much as BABIP does. The rule of thumb might be that a 900 OPS is more believable and you regress less than a 350 batting average on balls in play. In this in the distributions that are over here, this is a low spread of talent. It's a lot of luck on this end, low spread of talent. And on this end of the spectrum, you have a larger spread of talent and less luck. More skill, more talent spread, less luck over here. We see a lot of variation. In this case, we still have to regress more for the same reasons. Okay, if there's more variation in a low spread of talent case, we're going to regress more. Low spread of talent, low spread of talent, higher regression to the mean. To mean. And it's the opposite here. If there's a higher spread of talent, then we have a lower regression to the mean. The randomness here is how far away it is from the mean. This is the mean here, and this is the mean here. So randomness being high in this case means a higher regression to the mean, but the randomness is going to go away. The amount of randomness we see is largely affected by sample size. If your sample size is small, you're going to have a bigger regression term. If your sample size is large, you're going to regress less. You don't need to regress as much as you do in those small sample size. The law of large numbers is important here. Sample size does relate to the regression. The more we sample, the less we have to regress. The less we sample, the more we have to regress. These are the two keys. Again, to review, sample size is important. As sample size is small, we're going to have to regress more. And as the spread of talent is different, we're going to have to regress more or less depending on the spread of talent, and more or less depending on the sample size. So the amount of regression, what changes the regression to the mean, the amount we're regressing towards the mean, depends on two things. The spread of talent is more close, more on the luck side, we're going to have higher regression. If the sample size is low, we're going to have more regression too. If small sample size is around, that's going to lead to increased regression too. So remember two key factors: the spread of the talent, how it varies, and the sample size you have in your system.